So, what if a revolutionary energy source wasn't some new breakthrough, but a rediscovery? What if we found something that was forgotten? Today, we're going to dive into a pretty fascinating and, kind of controversial idea that suggests exactly that. This really bold claim comes from a researcher named George Egley. And what he's saying is that a super powerful energy process has been stumbled upon, not once, but over and over again, and then just lost to time. It's a heck of an idea, and it really sets the stage for a scientific mystery. So, what exactly is this forgotten fire? And really, how could something with this much potential just keep slipping through the cracks of scientific history? Let's find out. Okay, so Ellie's work is all about something he calls catalytic fusion. He got up on stage at the International Conference on Condensed Matter Nuclear Science and basically said, hey, this isn't a new idea. In fact, it's the original, overlooked form of what we now call LENR. That's the big question, isn't it? If this thing is real, how on earth did we lose track of it? Well, according to Egley, the story actually starts almost a century and a half ago with one of the most famous inventors in all of history. Right, so the first breadcrumb in this whole mystery leads us to a pretty unexpected place, Nikola Tesla's lab. Now, we all know him for alternating current, but his work was just full of weird anomalies and strange effects that, honestly, even he couldn't fully explain. Eagerly traces that very first hints of this forgotten energy all the way back to Tesla's carbon button ramp. And this thing, it wasn't just a light bulb. No, it was a device that did some very, very peculiar things that just defied the physics of the time. So Tesla himself noted the lamp was just ridiculously bright, so bright it hinted that more energy was coming out than was going in. But the science back then, well, it just didn't have the tools to figure out what was going on, especially not something as wild as elements changing, transmuting right there on the lamp's surface. He was stumped, and the discovery just got put on a shelf. So, what was the secret behind Tesla's crazy lamp? Well, to explain it, Aisley brings in a concept that is right at the heart of his entire theory. He calls it a condensed plasmoid. Now, try to picture this, a tiny, self-contained bubble just packed with millions of entangled electrons. Edgley is proposing that this little quasi-particle is the catalyst. It's the secret ingredient that makes this whole thing go. But here's the catch. To even get your head around these plasmoids, you have to challenge a really fundamental part of physics. Egley's claim is that our standard electrodynamics is incomplete because it doesn't fully account for what happens when electric charges don't just move in a line, but when they rotate. And this diagram from Egley himself illustrates his point perfectly. Look on the left, you've got the field from a static charge. Simple enough. In the middle, a moving charge, a current. We know that. But on the right, that's Egley's new idea. Charges that are rotating, spinning, and generating their own unique spin field. So let's just break this down. Standard physics gives us electric and magnetic fields from static and moving charges. Easily adds a third piece to that puzzle, a spin field from rotating charges. This is a fundamental challenge to how we describe our world. And if it's true, well, it could open up totally new ways to interact with matter and energy. Okay, so we have a historical mystery and a pretty radical new theory. But how do you actually go into a lab and create and harness these plasmoids? The answer, at least in concept, is surprisingly simple. It's all about sparks. The key is to create a series of really, really fast, transient spark discharges. It's in those super brief, super intense moments that these plasmoids are believed to just pop into existence. And this image here gives you a really good feel for the kind of environment we're talking about. It's inside these controlled plasma experiments, using these short, powerful electrical jolts, that researchers like Edgley are trying to recreate and study these effects. And here's the real payoff. The claimed coefficient of performance, or COP, is between 2 and 5. What does that mean in simple terms? It means for every 1 unit of electricity you put into the device, you get 2, 3, 4, maybe even 5 units out. I mean, come on, that's the definition of excess energy. If that can be proven to be stable and scalable, it would completely change everything about clean, decentralized power. So where does Egley's work actually fit into the bigger picture? Is this just a standalone curiosity, or is it part of some larger scientific quest? It's really important to see that catalytic fusion isn't happening in a vacuum. It is one of many, many different avenues being explored under this big umbrella of low-energy nuclear reactions, a field that,
Yeah, it's controversial, but it continues to attract very serious scientific attention.
And just look at the sheer variety of research that was presented at that same conference. You have scientists exploring everything from loading hydrogen into metal lattices to using lasers, even using sound waves to create cavitation in water. It is a huge global effort to try and understand and maybe, just maybe, harness these bizarre effects. Which, brings us right back to our big central question. Could it be that one of the keys to our energy future isn't about inventing something brand new, but about finally understanding a spark of an idea that's been waiting, forgotten, for over a century? It's a question that researchers in this field are absolutely determined to answer.